you can ask any questions which you have in the Q&A and the chat areas, and I'll try to answer them towards the end. So the purpose of today's webinar is to basically familiarize the new users of COMOSYS with the steel connections. Now, it might be a little longer. Normally, we try to keep it around 30 minutes. Might be a little longer, maybe 35, 40, but I'll try to keep it interesting. Now, basically, the idea is to go through all the different stages in a typical building and all the connections which are typically required in a normal building, and then make you get you familiarized with how these connections work. Now, before we start, let me just quickly say that, as you all know, COMOSYS is different from other detailing programs in the sense that it is also a finite element analysis program. So just want to make sure that you always know that your finite element model needs to be connected as much as possible. Make sure your nodes are all connected and you don't have disconnected members. This is just a general comment, not really related to today's webinar. Now, in most cases, you will have off-the-shelf macros, and I'm going to go through them. But sometimes these macros most times these macros will work. Sometimes they might not be designed for a specific situation. It doesn't mean you can't use them. You can still use them and maybe adjust them manually a little bit. But in other cases, they might not work entirely, and then you'll have to use your own custom connections. Now, let's start with the typical connections which I was mentioning. Let's start with a floor. So this is a typical floor, very simple. It doesn't need to be complicated, but just to take you through. So we have certain options for, now in a floor, what you will have is beam-to-beam connections, right? Places where there's a main beam and there's a secondary beam. And for these kinds of simple situations, you can use the end plate connection, for example. Under the beam-to-beam connections, you can use the end plate, and all you need to do is select the main one and the secondary one, and either right-click or choose another one at the backside. So I'm going to right-click over there, and you can see that. Let me turn off the cuts. You can see that the end plate connection can easily be made. Another option you can have, for example, is to use the stiffened end plate connection, which is also very commonly used. Let me just select the main one and the secondary one. In this case, there's only one secondary. And in this case, the stiffened end plate connection, as you know, is slightly different from the end plate connection. It's easier from the erection viewpoint, but it's got a slight eccentricity as well. But it's also very commonly used. Another option which you can have is the fin plate connection over here. Once again, you choose the main, you choose the secondary, and you do the right click a couple of times. It basically gives you a fin plate connection. This is also quite useful, basically to carry small shear loads, not when you have very high shear loads, or not also in situations where if you have too many bolts like that, it's going to start transferring moment as well. Another option which you could use is the beam-to-beam angle cleat connection. For example, I could use the main one and the secondary one and right-click, and basically you're using angles from one or both sides. This connection is also very commonly used in steel structures. You can use, for example, sometimes you have beams which are in the form of angles. So let me find one over here if I can. Yeah, maybe this is an angle. Yeah, the beam itself is just an angle profile. It's not an I-beam. So if you have that, what you can do is let me see, the fitting connection. Yeah, this one over here, the angle beam floor connection. In this case, you choose the main beam and the secondary beam, and immediately you get a simple connection if the main beam is an angle. So these are very commonly used, commonly occurring situations. Let me move on to a little more complicated ones in which you have some horizontal bracing as well. Now, horizontal bracing, as you can know, can be in several different formats. Let's try one. For example, if you already have a main and a secondary, and you have a fin plate connection like that, In that case, what you can do is, and you have a vertical and you have a horizontal brace coming in, what you can do is you can go to your bracing connections over here and choose the corner bolted gusset connection. And if you do that, you can select the main beam and the horizontal bracing, and then you can select the existing fin plate. And when you do that, you get this corner connection, which is very nice because there's no, it's not, you don't need to shift this at all. You can just directly use the fin plate, which already exists. But this might not be possible in all cases. So for example, you could have a situation, let's see, maybe this one we can try. So you could have a situation in which you want to use a stiffened end plate connection, for example, rather than the fin plate connection. So let me connect these two over here with a stiffened end plate connection. And as you can see, now I cannot connect this directly because it's already clashing. So what I can do is I can turn on my handles, for example. I can select this horizontal bracing, and I can then select the adjust handle over there and move it in the Y direction. So I'm going to move it, say, minus 150 millimeters in the Y direction. Now, as you can see, this has not broken my finite element model. The finite element point is still there, but I've just shifted it. And after I've done this shifting, I can go to my bolted gusset connection and say, I want to connect these two, and they're connected. Obviously, there's a clash over there. What I can do now is go inside the macro and enter maybe a reasonable number like 50 over there, see if it works. So that's enough for me. Maybe I don't want the left stiffener, something like that. And I can make my connection. Now, what I've basically done over here is I have shifted this profile's working point from there to a bit to the right, and that's allowed me to make the connection. This is very common in steel structures. You can also have these. For example, your bracings might actually be going under the beams, and in those cases also you can basically select the main beam and just directly do a connection between the bracings, which are passing basically under the beam, as you can see over here. These are all very commonly occurring situations. Now, another thing which is quite which you find very often with steel structures is studs on beams. When you have a composite floor and you basically want to pour concrete over it, you can come down to this stud and cladding group at the bottom. And here you have your stud connections. And all you need to do is basically just select any beam, and immediately your studs will be created. Basically, whatever beam you choose, your stud will be created on top of them, as you can see on the screen. What they look like, what the spacings are, obviously is given inside the macro. You can choose from a file. You can choose different types of studs. You can access the file from the preferences menu over there. You can have multiple types of studs built in. So stud 1, stud 2, stud 3. You can have your own, create your own company specifications. And these distances are given over here. You can create equal distances or give exact distances or give total counts, etc. So very easy to create these studs. Now, the next thing I want to move on to is beam to columns. This is also, of course, very common. So you have situations in which beams are coming in and connecting to columns. You can have different types of connections. If I go up over here, the second option over here is beam to column connections. And some of these are simple connections, while some of them are fixed connections. So for example, the beam to column end plate is a simple connection. Similarly, the beam to column stiffen end plate is also a kind of a simple connection. Beam to column fin plate is also a simple connection. So for example, let's try a few. Let me go in from that direction over here. Let me just delete this for the sake of clarity. So for example, this is a end plate connection. I can select the column and the beam and right click, and immediately my end plate connection is created from that side. Can undo that. I can also create a stiffened end plate connection like that, and right click. and my stiffen end plate connection is created from the web side. This can be done from the end plate connection can also be done from the flange side, but the stiffen end plate is only available from the web side. Similarly, if you have the fin plate option, once again you could select the column and the beam, and you could have a fin plate connection at that point as well. Now, let me just turn it around like that, yeah. So you can see the fin plate connection, and of course you can modify all the details over there. By the way, it's useful to mention that all these connections can behave exactly the way you want. You can set up your company standards so that they will connect according to the profile of the beam, according to the secondary profile, basically. So you won't need to make any manual modifications, or you won't need to actually go in and change the parameters. The moment you connect the beam, make the connection, it will automatically be created according to your company standards. Now, of course, these connections can also be fixed connections. So, for example, you have the haunch option. So you can go like that, and a haunch connection is created in which it's a fixed connection. And once again, like I said, this can behave according to your company standards by using a technology, what we call auto presets, intelligent presets. You don't need to select the preset even. The program will automatically select the appropriate preset depending on your beam. Now, you could have a situation in which you have a haunch coming in, let's say a haunch connection like this, and the haunch connection, let me just modify this a bit. Let me go inside and create a middle stiffener as well, like that. So you have the stiffener over here and the stiffener over here. And from the other side, I want to make a connection for the stiffen end plate, but we already have these two stiffeners. So what I can do is I can go to my beam to column stiffen end plate connection, select the column, select the beam, and instead of right-clicking, I can say I already have two existing stiffeners, this one and this one. And then I can right-click. And when I do that, it basically modifies those existing stiffeners and uses them for my stiffen end plate connection. Now, we could, of course, have a situation in which there would be a vertical bracing coming in as well. At this point, there could be a vertical bracing, and then you could use the corner bolted gusset on top of this to make your vertical bracing connections. Now, let me show you a few more areas which are very commonly occurring in steel structures. So you could have a situation in which there's a cantilever part of the structure coming out of your floor plan. Now, what you could do is let me go back to my beam-to-beam connections over here. And as you can see over here, there's this option of, there's a profile fitting, which basically means that I can select this one and this one, and immediately this profile is fitted. How is it fitted? It's fitted like that, as you just saw on the screen, by giving a little tolerance over there, and then you can it's welded over there. So that's one option. The other option is that you can do something. We have this option called the welded beam to beam fixed, which means that if you do that, I can select this one and this one, and basically it'll make sure that the bottom flange also meets with the bottom flange of the main beam. Let's do it over here, for example, with a bigger difference. And you can see that it basically extends it into a cantilever, making sure that the bottom flange loads are sort of transferred to the bottom flange of the main beam as well. What you can also do is you connect the top flanges with bolts. So, for example, we have over here beam to beam fixed connection, and you can just go like that, and you will create a fixed connection between the top flanges. So you can ensure that the moment is being transferred. These are very commonly occurring situations, like I mentioned. Now, one other very commonly occurring situation is obviously the splices. Splices are everywhere, and you can have splices. They can have normal splices for eye profiles, and all you need to do is just go down over here and go to the splice section, and just select the first one. Just select the first column and the second column. And the reason why it's not showing is because my up-down limits. Let me go back to my 3D view over here. see where I am. Yeah, there I am. So yeah, so I can just select my column and the other column, and my connection is made. Now this connection over here, which is the splice connection, actually also works for channels as well. So it doesn't need to be an eye profile. It could be a channel. It could also work for angles. So if it was just making a splice between angles or even twin profiles like back-to-back angles or cross angles, the same macro will allow you to create the splice connection. And there's another very comparatively a lot more complicated splice connection, which is the splice connection for cross profiles. Columns are very commonly used. Let me just show this only. So you know what this is the cross column, and it's got basically consists of an I profile and two T profiles. And for these ones, what you can do is you have a dedicated connection called the cross splice, and you just select the first column and the second column, and immediately your cross connection is made. Once again, no need to remind you that these connections can be set up in such a way that with a single click, it will basically do what your company standards are telling you to do. Now, you have similar situations with pipes as well. So you can have a pipe profile, and the pipe profile might need to have a splice. And there's some options. One is called the tube splice, in which you just select the pipes, and a very special pipe splice is created, which is basically working in basically the bolts are working in shear. So the bolts are not in tension, which is a preferred way of transferring the forces. Or you could do the classical end plate kind of splice, which is the one at the right over there. Now this one will also work for rectangular hollow sections as well as for eye profiles. Basically, end plate kind of slice, which is used. You will need a much thicker end plate, but it is possible and it is doable. So those are very useful splice connections. One more splice option I could show you is situations where the main so one of the section is a bigger one and the one continuing is a smaller one. So let me make it even more bigger. So let me call it an IHEA 500, for example. So you have something like that. And if you have that situation, you have this reduced section splice over here. And if you do that, just select this one and this one, and immediately you have this reduced section where you can once again set the parameters to your liking, but it will, you can also have the auto presets, which will just understand the situation and correctly apply it. Basically, it reduces the section and creates the splice for you. You can also be working with trusses, and trusses are typically done with a welded gusset connection. So you have under the bracing connections, you have the bolted gusset, the corner bolted gusset, the welded and the corner welded gusset. So typically, if you use the welded gusset, you will go in and you will select the top chord, and you will select the diagonals, right click, and your welded gusset connection can easily be made. Or I could do this one and this one and this one and this one, right click. You can, of course, use the bolted gusset option as well, depending on your truss type, or you could have a mixed connection in which two of them are welded, but the third one is bolted because you want a splice over there. Now, one more thing you might want to do is the apex point, for example, over here. Not sure which one to use for that. Let me see if I go down over here, there are some truss connections, and maybe it's this one. Yeah. So this one asks for an apex truss. So this one, maybe this one. I'm not really sure, but let's see. Yeah, basically, by electing all of them together, you can create this apex connection. And the difference between this one is that the gusset is obviously now slightly modified over there. You can also do a truss end plate, which is basically you go like that. You select the column, you select this one and right click, and you have this connection, which basically it's an end plate connection, which connects the bottom chord or even the top chord to the column. This is obviously the case in which you're transferring forces. If you want a roller connection, then you will do a different one. Now, one other thing which is quite commonly found in structures is vertical braces. So for example, over here I have um, I-beams as my vertical braces, and I want to connect them. So let me go to my bracing connections. I can use the bolted gusset one. Like I said, it's a good idea to, if I turn on my handles again, so let's see the size of this beam is 400. So if I just go in and move my adjust point to minus 200 so that it comes to the middle of the beam like that. That's much better. I can do the same for the other one and go like that. So both of them are now in the middle of the beam, the working point, but the finite element model has not been broken. And once that is achieved, I can go to my bolted gusset command over here, select the beam, select the first brace, select the second brace, right click, and my connection is made. You can modify the interbolt distances. You can set up, like I said, COMOSYS so that it automatically brings the right interbolt distance from a file, or you can go inside and put a number over there, for example, and modify those distances according to your liking. You can also have pipes. Like I said over here, you can use the same command, this one and this one, this one, and right click, and you can have a pipe. Basically, what you're noting over here is that the same macro is being used again and again for different types of vertical braces. Let's go in and try to use it for example, a twin profile, a back-to-back angle in this case. Once again, the same command, I can use my column and my secondary one, and my connection is made very easily. Now, one thing I would like to mention is that creating, let me, for example, create this one and this one and this one over here. And the creation of batten plates is also quite easy inside COMOSYS. So if I go into, let me see where they are. It's difficult to find them sometimes. They're not here. I think they're in the... Yeah, over here under the miscellaneous steel detailing sections. If I choose the batten plate command, all I need to do is just select my twin profile, and the batten plates are created according to my settings. I can just select another twin profile, and the batten plates will be created very easily. Now let me move on with apex haunches are very commonly used. So you have a situation like this. This is a beam-to-beam connection. If I go to the top, to my beam-to-beam section. Over here, you have the apex haunch. Just select the first beam, select the second beam, and you have the apex haunch created. Once again, the settings can be modified. Girts and purlins, of course, the biggest part of the structure in some ways. If you come to girts, for example, let me come down over here. After the splice, we have the purlins and girts. Over here, if I just go to the girts selection, just select the column, and select a girt, right click, you can create a connection between the column and the girt. And this has different options. So if I press enter over there, open the macro, you can see I can do it as a bracket as well. I can create a bracket over there. Or I can create a bracket without a cut over there as well, which is different. So different options. For even I can use folded plates, or I have the option to use the same profile, basically using the same girt profile as a hanging member for the top. So different options are available, once again, from the same one, from the same command. You could have situations in which the girt is actually, so this is a situation in which the girt is partial, it's not reaching the column, so I can't connect it to the column, but I need to connect it somehow to the beam over here. It's a girt, maybe there's a vertical member going like that, but this girt needs to be connected to this beam over here. So for that, we have this girt beam command over here under the purlins and girts. And what we do is we select the beam, we select the girt, and then we can we can say right click, and then it asks for a point. And I can give it a point, like I can select a point over here and say DY 100, for example. And when I do that, a connection of this sort is created between the girt and the beam over there. Now, a similar situation exists with purlins. Once again, if I go to my purlins, I can go to my purlin connection over here, select the main beam, select this one, right click. I can get my angle cleat connection over there. I can reverse the cleat if I want to. I can create the folded plate type also if I wanted to. So I can create a folded plate connection. Once again, the other options are also available. One thing I want to talk about very quickly is if you have a situation in which the purlins are coming at a kind of an angle like that, and these kinds of situations occur in circular or rounded areas. So if you have a situation like that and it's basically a skewed connection of purlins, COMOSYS will intelligently recognize that situation. So if you select the beam and select the first and the second purlin, it will automatically create this kind of a connection. Let me just show you what it's done. It has, or let me just turn this on, turn off this. Say select assembly, show only. So it has basically created this little contraption over here so that the purlin can be connected from this side and from that side quite easily. Let's just show all. We could have situations in which the purlins are like Z profiles, right? So this is a Z profile, and what I can do is I can go into my purlin command and say I want to create a connection between this one and this one. But then if I go inside the macro, I can actually tell it to create an overlapped Z profile. If I do that, a different kind of the purlins are extended on both sides, and because they're very thin walled, and they're connected from the back side as shown. And then what I can also do is, if I go to the Z purlin type, I can turn on these little struts, and we have this option, which is very typically used in smaller shed type structures, lightweight. So basically the same command, the same purlin command can be used extensively for different types of situations. Let's go on to sag rods. So if you already have your girts, for example, what you could do is if I go down there somewhere, let's see. Yeah, in the structural members, there's something called create sag rods. And all I need to do is select my first girt and my last girt at the top over there and right click. And immediately all my sag rods are created. And once they are created, I can actually make the connections for them as well, very, very easily. Sometimes in steel structures, we have these situations in which a beam is passing from under another beam, like this monorail is passing from below this beam over there. And so if I go back to my beam-to-beam connections at the top, very top, you see these options of hanging beams, beam on beam and hanging beams. If I choose this one, I don't know what the order is, so let me just try. Yeah, so basically by selecting the two, you can create a connection between those hanging beams. You can also use the other one, but that's only for when they're parallel. They're not parallel in this case. Sorry, exactly perpendicular. One is at an angle. But even then, if you notice that a particular macro is not working exactly as you wanted, it doesn't mean that's you need to do it entirely manually. What you could still do is use the handles to make your modifications. So, for example, I could select this plate, and instead of selecting this and this, instead of keeping them at 92, I could make them 150. Extend them on both sides, move the bolts if I wanted to, for example, basically any manual modification which you might need to do. What I could then do is maybe if I just select this area over here, say show only, so that it doesn't get in my way. Yeah, so I can see that this one is not extending. This pink one is not extending to the top. I can just select this edge over there and say just move to the surface. And when I do that, it's extended. So when a macro doesn't work perfectly, it doesn't mean that you're stuck with it. You can still use it as much as you can, and then continue from there manually. Now, let me turn everything on again. Base plates, once again, very common everywhere. You have your normal I-beam, so you can, if I go down there, after the purlins, I think, yeah, you have the base plate options. Very simply, just select any column and your base plate will be created over there. You can also have base plates for different types. You can create a base plate over here, for example, using this one uh, over there, for example, and you can create this raised base plate in which, because if the loads are high and you want the base plate to behave like an I-beam, you can do that. You can have base plates for your hollow sections. So if a circular hollow section or a rectangular hollow section, you can have your base plates around that very quickly. Now, if you wanted anchor bolts, so here's a base plate. If you wanted anchor bolts, you would need to go to the formwork part because they're a bit misplaced in some ways. But let's go down. Yeah, embedded objects. Embedded objects under the formwork parts will give you the anchor bolts option. And if you select the anchor bolts, you can either select a point, so you can show it the various holes, and then it'll basically create anchor bolts over there. Or you can just right click and then select the entire plate. And when you do that, it'll basically find all the bolts in that base plate and create your anchor bolts for you. Now, obviously, you have many different options with these anchor bolts. You can create the simple ones like I showed, or you can create a headed one like that. Let me just move this out of the way a bit. What you can do is you can create the C type, or you can create the H type. So basically different options, and all these options are controllable by, if you go to the preferences directory over here, and you go to the anchor bolts defaults, this is a text file which you can easily use to create as many custom anchor bolts as you want for different diameters of holes. And once they're set up, once this file is set up, your anchor bolts will be created according to your company standards. So very, very convenient way to create your anchor bolts. Now, another thing which is very commonly occurring is cladding, for example. So you could have a facade like this, and you want cladding over it. So what you do is, if you go to tools over here, you have something called these informative objects, and you have things like informative polygons. These are closed polygons. You can create these polygons. This is a informative polygon. If I double click on that, it's basically a I can go, how I can create it. I can go over, so I can go over my from here to here to here. If I just showed that only, you will see it. Show only selected. This is what I've basically followed the outline of the facade. This is the informative polygon. Let's say show all again. And if I go to my cladding, studs and cladding menu, over here I have got something called the multi-cladding. Now if I choose that, it asks for that informative polygon. So I just select this one, and I right click, and then it asks for the origin. So I can basically show this one. It asks for an X direction. So I can once again say DX 1000 over here. And it asks for the basically the Y direction, the direction of the thing. And I just say DZ 1000 over there, like that. And immediately my entire cladding for that facade is created, and this is created in little different parts. So it's basically detailed, the full one. And if you go inside, you can actually change these. You can go to the vendor. You can change the vendor. You can change the class. You can change the form. You can have all these different types of claddings built in. These are also, by the way, savable if you go to your preferences directory. Inside, there's something called this directory called structural objects. If you go inside that, you have this directory called claddings. And inside that one, you have this text file, which you can use too. You can have multiple files as well, in which you can set up all your cladding vendors. And once that is set up, you can then just create your claddings very easily. Now over here, I see this monorail sticking out of the cladding, and I want to actually open a hole in the cladding over there. So we have something called multi-cladding hole over here. So what we do is we select any of these claddings, and then it says right click. I'm sorry. Let me do it again. Close. You select this one, and then it asks for the hole. So I've created this polygon over here, which you can see the blue line, and I'm going to just select that, and I'm going to say right click. And when I do that, it's going to. I'm sorry, I couldn't manage it this time for some reason. It's supposed to take a projection. Select claddings to be drilled. No, maybe I'm misusing it. Let me try again. No, I think maybe I need to move this into that plane. But anyway, what you can do is you can use this command over here to create a hole in the existing claddings, and that'll basically work for you. Now you can also use this command over here for the flashings. So if I open, you can create the flashings around the claddings to finish off, and then these can be drawn automatically as well. If you have stairs, of course, stairs are everywhere. In every structure, there's stairs as well. So if you have some stairs, what you could do is, for example, you have a stringers like that. You can go to your beam to beam menu over here, and you have this fitting connection over here. So you could, for example, select this one and basically fit them. Select this one and fit them together. And then you could come down and go to, let's see over here. We have the stringer holes under the ancillary steelwork section. If I do that, it asks for basically the first stringer and the second stringer. And it creates your threads along with any holes which might be required. These are all, you can set these up in your files very easily. You can then go on and create your connections over here, basically using the beam to beam macros as well. So very convenient to quickly add your stairs and threads. Let's go on to handrails. So for example, what you could do is you could create handrails. So this is once again under the ancillary steelwork section. You could just select any beam, right click, and then you could select 2 points, or just right click again and it'll create the handrail at that point. So you could just select the points as well, or you could just move it on the section. So let me use that, for example, to go to the little cantilever area which we had over here. If you remember, we had this cantilever area. I can go in and basically create my handrail on that beam, and on that beam over there. And once I've created them, I can actually connect these handrails to each other as well by using what we call the handrail connection. And if I do that, all I need to do is just select any members of the two handrails like that. And the handrails will be connected not only at that level, but at this level as well, and at this level as well. So just this one and this one, and immediately you have your connected handrail going all around. You can obviously do the same for an inclined handrail as well. So like that, something like that. And then you could once again connect the two handles like that and like that. And you'll quickly have created your handrail around stairs as well. One little final thing I want to mention is the floor modeling. So let me just go to the plus 8,000 level. This is a level in which we have created these orange or yellow polygons. And how we did that was basically go to the floors over here, and we created this floor, and then we basically asked it to find the polygon. So it went and found all this connectivity between the beams very conveniently. But what I want to show is that once we have these yellow polygons, which can be created with a single click, all you need to do is just select all of them like that and go to your floor modeler over here. and just click it. And when you do that, immediately all your gratings on that floor will be created automatically. Now, that's very, very convenient because this is a very time-consuming job. And if you notice, they're even going around the handrail. They're even going around the columns. They're even going around the splices. So they're very aware of the situation. They're going around the columns. So each and every one of them can be created, and the same thing can be used for creating checkered plates as well if you wanted to. You can create checkered plates, gratings, expanded sheets, diamond plates. Several different options are available. Very quickly, you can create these at a single click, and then obviously the drawings are also later on created automatically. Now, very quickly, I'll just finish it off because we're running out of time. We can go back to the 3D view. Here we have a curved beam. So you have your options of, if you go back to my beam to beam connections at the top, I can use my beam to beam. I can select this one over here. I can select the main beam and the secondary beam and right click, and my end plate is connection is made. I can do the same with my stiffened end plate, for example, very easily, or I could create a fin plate connection very easily. So basically the curved beam connections are also created very, very easily. Now, I just wanted to take you very quickly through these connections, just to give you an idea. This is a large building. Basically, by repetitive usage of these connections, you can go through all these steps and finish your job off very easily. Just the purpose of this webinar was to basically take you through all the different types of connections which are typically needed. So I hope you enjoyed it. I'm going to stop and see if you have any questions.